Hey friends, welcome to NIKRA'S Expert Learning. So hope you all have seen the previous videos regarding the civil engineering concepts, basics we have discussed. So today we are studying another important topic, the basic definitions and simple tests. So this is a syllabus copy for all AE and JE exams generally seen. So we have studied the phase diagrams and origin I'll be explaining. So now we are studying the definitions, the void ratio, porosity, degree of saturation, everything in one single video. So this is that video. So first of all, let us see what are the terms, the symbols we are having in this. So first we are having E. E is void ratio. Okay, N is porosity and W is the moisture content in this. So S is specific gravity. So I'll explain you everything, what is void ratio, what is porosity, what is moisture content in this video. So first we are studying one by one. Okay, so this is the like the entire symbol and concept notation in one single page. Okay, you can just take a screenshot of it. I'll just remove this. Okay, so this is the main concept of geotechnical engineering. So first let us see what is void ratio. So it is represented by letter E. E is equals to VV by VS. That is, it is defined as the ratio of volume of voids to volume of solids. Okay, so whenever we are understanding, so in the previous video we have seen phase diagram. So phase diagram, we are explaining everything in terms of voids. So we are just explaining it to be a two-phase diagram or three-phase diagram based on what is filled in the voids. So here we are understanding the volume of voids to volume of solids. It is equal to the void ratio E. So it is generally greater than 0. The void ratio is generally greater than 0, and for some soils it will also be greater than 1. So for some soils, okay. And remember, the void ratio of coarse grain soil is generally smaller than that of the fine grain soil. Okay, remember this. So basic understanding of what is void ratio, that is volume of voids to volume of solids. It is generally greater than 0, and E of coarse grain soils is generally smaller than that of a fine grain soil. Okay, next coming to porosity, N. So porosity is nothing but the ratio of volume of voids to total volume. Okay, so in void ratio we are telling it with respect to volume of solids, but in porosity we will be giving it with respect to the total volume. Okay, and the N value is generally greater than 0 but less than 1. So here we should understand one thing, both void ratio and porosity is nothing but a measure of degree of denseness in the soil or looseness. So by knowing this value, we'll understand how dense or loose the soil is. So the denseness or how loose the soil is, the looseness of soil. Okay, so this is what we'll be understanding from that value. And next we are having SR. This is degree of saturation. So in this we are understanding the ratio of volume of water to the volume of voids. So in the degree of saturation we are understanding what is the quantity of voids filled with water with respect to total voids. Okay, so with respect to total voids, how much amount of void is filled with water? So we are understanding the degree of the saturation. Okay, and it is generally, this value is greater than or equal to 0 to less than or equal to 100. So when I am saying 100, it is fully saturated. So as I have told you in the previous video, we have cases like fully saturated, partially saturated, okay, and totally dry. Okay, so here we are understanding based on the degree of saturation, we'll be telling if it is a dry soil or partially saturated soil or fully saturated soil. Okay, so when I am saying dry soil, that means SR is equals to 0. Okay, but when I am telling about the saturated soil, the fully saturated soil, in that case, the volume of voids is equals to volume of water. That is, it is completely filled with water, right? So I can just put the entire, the volume of voids can be replaced by volume of water. So all of this would be cancelled. The value would be 100%. So in this case, the degree of saturation would be 100%. So here we have learned three terms. First, the void ratio, porosity, and degree of saturation. Okay. So coming to the next topic or next definition, that is NA. NA is percentage of air voids. Okay. So when I am saying percentage of air voids, again, we are talking about the ratio of volume of air to the total volume. Okay, so understand. So when I'm talking about degree of saturation, it is volume of water with respect to volume of voids. Okay, but here when I'm talking about percentage of air voids, it is VA by V. Okay, and N is porosity, that is VV by V. Okay, and the value is generally the NA value is greater than or equal to 0 and less than or equal to N, again porosity. So this is with respect to porosity, so that is why the denominator of both is V. Okay, and next we are talking about the air content. Air content is same as degree of saturation. So in degree of saturation, what we have written, it is VW by VV, right? So in air content, it is just VA by VV. Okay, even this will be, the value range would be 0 to 100%. Okay, so just understand the terms. First we are talking about, so till now we have discussed 5 terms. First, the void ratio of volume of voids to volume of solids. Next, the porosity, volume of voids to total volume. Next, SR, VW by VV. Okay, so similarly, like N, we have percentage of air voids, that is VA by V. Okay, and similar to the degree of saturation, we have AC, that is volume of air by volume of voids. Okay, so this is the main definition format. And next we have water content, weight of water to weight of solids. See, when I'm talking about water content, in this we are calculating the ratio of weight of water to weight of solids. So in the weight of solids, what is the ratio of water? Okay, so this is generally greater than or equal to 0. Okay, so when I'm talking about the dry soil, this will be equal to 0. For saturated soil, it will be greater than 0. This is for dry soil and this is for saturated soil. Okay, so just understand the difference. And next we are coming to, so this is the main definition part. Okay, so here we have studied 6 definitions, 6 parts. First, the void ratio, porosity, degree of saturation, okay, the percentage of air voids, air content, and third one is water content. The water content is nothing but, so all of these are in volumes. Okay, these 5 things are in volumes, but when we are talking about the water content, here we are calculating the ratio of weights. Okay, so 6 things, this is mainly done. So we are done with the basic part. Okay, so now let's see the bulk unit weight and all the submerged weights and everything. Okay, here we have studied 6 definitions and coming to the next one, that is bulk unit weight. So remember, density is always weight by volume. Density is always weight by volume. So when I am talking about bulk unit weight, it is also defined as total weight per volume. Total weight per volume. Okay, total weight per volume. So also known as wet unit weight or total unit weight. So when I'm saying bulk, it can be called as wet or total unit weight. Okay, it is simple one. So when I'm talking about dry unit weight, see, that was wet one, but when I'm talking about the dry unit weight, it is defined as weight of solids by volume. Because as I'm saying dry, here we cannot consider the wet part of the soil. So we are only considering the dry part, that is soil and air. And we know weight of the air is 0, negligible. We studied this in the phase diagram. So we are only considering the weight of solids with respect to volume. Only thing we have to remember is density is equals to weight by volume. From this we'll be getting the entire like for all things, the weights. First the bulk unit weight, second is the dry unit weight. Bulk is also called wet or total unit weight. Okay, and next we are having saturated unit weight. So saturated unit weight is gamma sat. So for this we'll take weight of the saturated soil divided by the volume. Okay, and when I'm talking about submerged unit weight, it will be submerged. So it is represented as gamma dash. So gamma dash is equals to weight of the submerged soil divided by volume. Okay, and based on the Archimedes principle, remember that gamma submerged is equals to saturated unit weight minus water unit weight. Okay, so when I am talking about the soil solids, like unit weight of soil solids, this will be generally asked, very rarely asked, but you have to be remembering this. So this is again weight of solids by volume of solids. So when I am talking about solids particularly, this will be weight of solids by volume of solids. Okay, so here we have studied first the bulk unit weight. Bulk is also called Veta total, and next we have studied dry unit weight, and then we have studied saturated. For saturated is saturated weight. For submerged it is submerged weight. So when we know in some questions in short forms they'll be asking what is the saturated weight of the soil if the submerged unit weight is this much. So in that case we know what is the unit weight of water, right? So in that we'll be subtracting this value or adding this value. We'll be using this equation to solve the third unknown value. If we know two values, what will be the third unknown? We will just be substituting that in this value. Okay, in the next video we'll be understanding like the interrelations of this of all these terms. Okay, next we have specific gravity. Specific gravity is, see, it is defined as the ratio of weight of a given volume of solids to weight of a volume of water. Okay, so it is nothing but unit weight of solids to unit weight of water. Okay, now let's summarize the entire thing, the definitions. So first we are having 6 definitions. 6 main definitions is E, N, SR, Na, AC and W. Okay, this 6 definitions. E is Vv by Vs with respect to solids. Porosity is Vv by V, and SR is Vw by Vv. Okay, this is with respect to volume, this is with respect to voids. So understand, similarly in air, so this is for water, right? Degree of saturation is for water. Similarly we are having air voids. So percentage of air voids is nothing but Na. Na is equals to Va by V. So this is similar to this. And similar to degree of saturation for water, we are also having air content. Air content is Va by Vv. So here Vv, the denominator for both is same. Here V is same, here Vv is same. Okay, the denominator is same. And next, water content, this is the only one in which weights are like calculated as a ratio. So weight of water to weight of solids. Okay, so next we are having, so here we have covered 6 definitions. And next coming to 5 definitions. That is bulk unit weight is weight by volume. This is bulk or total or wet. Next we are having dry. Okay, so gamma dry, it is weight of solids by volume. As I have told, other things are removed, only solids are left for dry one. Okay, dry by volume. When I am saying saturated, it is weight of saturated soil divided by, like the bulk weight of soil divided by volume. Submerged, weight of submerged weight, the ratio of submerged weight to the volume. And the saturated is nothing but saturated minus, the submerged is equals to saturated minus the water weight. Okay, and remember, very important thing, last concluding part, the gamma S is always greater than gamma saturated, and it is greater than gamma, it is greater than gamma dry, and gamma dry is greater than gamma submerged. Okay, gamma S is constant for some soil. Okay, it is always greater than saturated condition, and it is greater than the bulk one. Bulk is greater than dry. So in dry we are adding water, right? So dry is only the solid weight, but here it is total weight in bulk. And in saturated I am also adding the water weight to this, so that's why saturated is more. and combinedly the soil weight is more greater than everything. Okay, so when I'm saying submerged, more than submerged, it is dry. So to dry weight, we are adding more soil weight, that is gamma, and gamma to are adding water to make it saturate. So that is why this is more, and to increase that, like to further, like the soil one would be higher of all. So similarly, we are covering the entire civil engineering syllabus for state and central exams using some clear tricks and concepts. So, and also we are posting the civil engineering previous year questions in the WhatsApp community. So if you want, just comment down for the link, or you can find it in the description of the channel. And all the content is already provided in the WhatsApp community. So check the channel description, subscribe, and stay connected for more such upcoming videos. Thank you.